All right. Hello, everybody. Thank you guys for joining us in our session, How to Ensure Configuration Compliance. My name is Masanya Scott. I'm a business development manager for two AWS services, AWS Control Tower, as well as AWS Service Catalog. And I also consider myself a cloud operations evangelist. With me today is Sid Gupta, who's the product manager for AWS Config. And we're honored to have Manish Mohiti, who's the global head for cloud engineering at the Geoffreys Group. And we're going to just give you guys some best approaches for ensuring configuration compliance. So from an agenda perspective, we'll talk about some of the challenges, and you guys will probably be familiar with those challenges. We'll give you some best practices, and then Manish will come up and explain how Geoffreys Group uses AWS management tools to ensure configuration compliance. And then finally, we'll wrap up, and if we have some time, we'll do a QA. So we do have some related sessions. Feel free, in terms of governance, to take a picture of this. Those sessions will be on YouTube, some of them, depending on what type of session they are, but we just want you guys to know that there are multiple sessions on governance. So let's talk about challenges, okay? You know, you have your builders, your developers, whatever you may call them, engineers. They want to be innovative, have speed and agility. They've created a proof of concept. They're using AWS for provisioning their resources for whatever solution they're trying to do. And now they're ready to move that to prod, okay? And so they're starting that process, and then all of a sudden, either compliance or security stops them and says, wait, what is this? What are you doing? Have you aligned it to our policies and controls? Does it meet all the regulatory requirements we have? How many people went through something similar to that? Don't raise your hands, just blink, okay? Because compliance might be next to you, so I just want you to just blink, all right? All right, okay. So you guys are familiar with that situation. And so, like I stated, builders want to move fast, be innovative, get something out there, see the results of what they've thought of. And IT or your governance wants to make sure that they mitigate the risk, protect your brand, and continue to adhere to the governance of the organization. So how do you address both of those? How do you address compliance now that you're moving from infrastructure being in some rack and stack in a data center to infrastructure as code? How do you educate your stakeholders from your leadership to your compliance, your security, finance? How do you educate them on what to do? And finally, how do you report to your auditors who may not be familiar with cloud on what we're moving and how we're transitioning? Do we align to software as code, or do we change the dynamic and make additional considerations for the cloud? So from a best practice approach, one of the things we want to make sure you guys realize is that with AWS management and governance tools, you can have both agility and balanced governance as well. And if you guys don't remember anything, I know it's kind of late in the afternoon and y'all are ready to have some fun. If you don't remember anything else, we recommend that you pre-configure compliance into your designs. So begin with the end in mind and make sure that you're meeting those needs for your policies. So from a best practice approach, we have four kind of categories. The other thing you'll hear today are we're going to feature kind of controls from a preventative perspective as well as a detective perspective, okay? And then from establishing the standards, what we want to do is make sure those four approaches are establishing your standards, designing your configurations, launching those products, and then finally managing the resources that you're provisioning. So let's start with establishing standards. And from that, what we recommend you do is identify what are the requirements in each one of your environments. What are the policies that you must adhere to? And as you move towards production, things are more strict, but you got to understand what that is and how can you create templates and designs that meet all your requirements in every business need. As we move on to designing configurations, let's think about that application stack. On the top, you have your code, your configurations, your repositories, and then for the resources that that code runs on, from a cloud service configuration perspective, you'll have the templates, you'll have the configurations for security, metadata, and we call them tags. You'll have your operational rules, and you'll have your detective controls, okay? We recommend that you templatize your provisioning of resources so that you can have a consistent delivery mechanism and so you can have proof of how things are moving into the cloud. And so with those templates, we want those templates to be immutable. And you know, I love the word immutable, but I just want to just make it simple, unchanging, okay? And then align those configurations to your different environments as the previous state showed. We also want you to do those detective controls by enabling AWS Config rules and then enabling auditing so that you can prove to your auditors, your leadership, that things are running as you have planned and as you have expected them to run. Now, so when we're talking about provisioning or launching the products, we have AWS CloudFormation, which is our infrastructure as code orchestration service. And on top of AWS CloudFormation, we have another service called AWS Service Catalog that enables you to provision products in a template, consistent manner. It enables self-service for engineers. AWS Service Catalog as a proxy not only does that, but it also separates the permissions from your engineers. So your engineers have access to the products that you want them to provision, but then we have launch constraints that enables those provisionings for your resources. And what those launch constraints do is give you the ability to let AWS Catalog do the provisioning without giving that direct access to your builders. Now, I know some of you are saying, well, Sonia, we want to be innovative. We don't want, you know, we want to give our developers freedom. And that's fine, but if you think about, if you're a platform engineer in here, how many times does somebody come to you and ask you, can you give me this environment? Can you spin up this account? Can you do those different things? If you enabled self-service and gave them the permission to do that, then you and your team could go and focus on doing something else, right? Improving what you're doing and architecting for improvement and efficiency. And so from a service catalog perspective and configurations, we do a couple of areas that I want to call out. Tag options. And those tag options, I call them standardized tags. And what you do is you associate those tags to the products. And products are nothing but CloudFormation templates in AWS Service Catalog. And anytime that product is provisioned, those tags are automatically placed onto that particular resource or resources. The other thing we do is enable stack sets where you could provision a product to multiple accounts or multiple regions, depending on your use case. And finally, from a compliance perspective, we know that customers have enterprise service management tools or agile development tools that they use and they've stated and declared in their compliance auditors as their repositories for certain findings. So we also have enabled through two connectors. One is for ServiceNow. We've done a 5th iteration of that recently launched. That allows you to provision products in ServiceNow Service Catalog, but AWS Service Catalog serves as the source of truth. The other is brand new. We just launched this last week, is to Atlassian Jira Service Desk. And what it does is it allows you to provision AWS products as a request type in Jira Service Desk. So it gives you that ability to be agile, whether it's from an enterprise view or from a DevOps builder view to provisioning resources in a consistent manner. And like I stated to you, the administrators of Service Catalog or your cloud admins basically set up the portfolios, can collect them and provide different products within those portfolios for organization, and then give the ability to put the launch constraints and the permissions. And finally, end users just do self-service. And they have 3 options now of doing it, either through the console. 80% of AWS Service Catalog is provisioned through command line. And then we also are using additional opportunity through other tooling, such as ServiceNow and Atlassian Jira Service Desk. So what I want to do now, we're going to, like I told you, we're going to focus on controls from a preventative and a detective. I just talked about CloudFormation and AWS Service Catalog from a preventative point of view. We're going to do a demo, and I'll walk you through that demo process for preventative, and then I'll turn it over to Sid to do the detective and managing of resources. So what we're going to do is this quick use case will enable an end user, a developer, to order a web server through a request type in Atlassian Jira Service Desk. And then that web server will be provisioned into AWS account. So they're going to go to the Help Center in Atlassian, request the AWS product. They're going to input some summary details that are required as baseline for a Jira Service Desk request type. Then they're going to find which product they want to provision. So we're going to say a web server. And what we expose to the end users are the versions of the product, if there are multiple versions. And then we also expose the parameters for that particular product. So you see now that the end user has picked their version. They're going to pick their parameters, leave some default, and select the T2 medium as their particular instance they want to provision. Now notice here, we have tag options. So the end user selected their tag option, and now they click create, which is going to go ahead and send that to a request. Before it gets requested, there's an approval workflow associated through Atlassian, and so now they're going to, as an administrator, that person just automatically approved it. It may be another group, and so that product's launching now. And once that product launches, we put in the details that the customer end user requested, and then we start seeing details coming back from AWS to this particular Atlassian Jira Service Desk instance on what they want to provision. Now I'm showing you that product provisioned, and it's in that initializing state. The one thing I also wanted to point out is show you that, like I stated, those tag options, because it provisioned, it automatically put those tags on that EC2 instance. Now, how this was done was, first, everything was set up in AWS Service Catalog. Since we're the source of truth, we put it in a portfolio, which is nothing but an organization of products. Selected that web server. And then there are 3 different versions. The developer chose the LAMP Stack 3 version. And then we also in AWS Service Catalog have an integration with Systems Manager to put SSM documentations for post-provisioning. So you can start, stop, run EC2 instance, reboot it, or do a custom document as well. And then we show in AWS Service Catalog that that product is in the provisioning stage. Now, once it goes through that provisioning stage, you'll see in Jira that it's saying that it succeeded. So Jira already knows that it succeeded, but it's still going to cascade some additional information and turn it to the state of available. Now, what I did was I went to another request, earlier request, to show you that you can do post-provisioning actions such as update, terminate, and do system manager documents. So I'm changing that instance right there from a previous request, lowering it down to a smaller T2 family instance. And what just happened is I got a notification that my other product in Jira Service Desk that I requested is now available in AWS as well. So the whole goal of that is to show that you can provide consistent delivery, you can provide different products, either at the console, at a command line, or through a connector that we've developed and enabled for customers. So we've talked about 3 things, and establishing a foundation of standards. We talked about design configurations, and then we talked about how do you launch or provision your products. I'm going to turn it now over to Sid, who's going to talk to you about how to manage resources, and then his core focus is on detective controls. Sid?
Thanks, Masonia. Hello, everyone. My name is Sid, and I'm the product manager at AWS. So you heard from Masonia about some of the preventative controls that you need to put in place so that your resources don't end up being misconfigured. So oftentimes, you may come across a situation that some out-of-band changes are made. Either someone logged into the console outside of Service Catalog or made some changes through the API or CLI. And so now you have a situation where your resources are misconfigured. So as a best practice recommendation, we recommend not just having preventative controls, but also detective controls. So detective control is a set of controls that you can configure so that they kick in post-provisioning of the resource. So the main intent of these post-provisioning checks or detective checks are to find out whether your resources are compliant with best practices. Are they compliant with your internal policies? You may have your InfoSec teams or internal governance teams that have policies defined for various services and resources. You may also have some requirements that are set forth by regulatory bodies like PCI or HIPAA. But in order to have an effective detective control in place, you need to know a few things. For example, you need to know what resources currently exist in your account. What does their configuration look like? And what does the configuration look like at a certain point in time in the past? What relationships exist between your resources? And finally, what is the actual list of resources that are non-compliant with my policies? So in short, you need a real-time configuration auditor in the cloud. Now, the key word here is real-time, because as you may know, the resources in the cloud are dynamic. You have things like auto-scaling mechanisms or spot instances where these resources come and go within a matter of few minutes. So even in that short duration, it's important to make sure that those resources don't violate your policies. So that's where AWS Config comes in handy. AWS Config is a native agentless service, and it automatically discovers resources in your account. It tracks changes to the configuration of your resources, and it maintains that configuration history for a period of 7 years by default. Now, this information is valuable if you're in a heavily regulated industry and you want to show this data to your auditors. You can show the change log for an extended period of time. And since AWS Config is capturing the configuration state, you can also compare that configuration against your desired state or policies that you can define using config rules. AWS Config is also integrated with AWS organizations. So if you're someone who is managing a number of accounts spread across various regions, AWS Config can give you an aggregated view of your configuration and compliance across your entire organization. And lastly, if you have investments already in your own ITSM tools like ServiceNow or any other BMC Remedy or any other tool, you can put the config data into that tool and then have your change management, incident management workflows kick in. So I'm super excited to talk about some of our recent launches in AWS Config. A couple of months ago, we launched automatic remediation of config rules. So previously, config as a detective control checked the resource against policies and then alerted you in real time using Amazon SNS notifications or CloudWatch events that this resource has violated a certain rule. But now with automatic remediation, you can configure an action that you could take, that config could take, to remediate that resource. So for example, if you have a config rule that looks for wide open security groups on port 22, you can have a remediation action that goes and fixes that security group settings. Now behind the scenes, we use Systems Manager automation documents. That's where you can define your remediation action. Now, the action could be as simple as sending a notification to someone or raising a ticket in an ITSM tool. Because a lot of times, customers have various steps or workflows in place where they don't want to take a remediation action immediately, but they want to kick in a workflow. The other feature that we just launched last week is something known as conformance packs. So imagine if you are someone who's got like several accounts, like maybe 50 accounts, and spread across 3 different regions. And you have a set of policies, or let's say if you're subject to PCI, there are about 50 or 60 different checks that you need to trigger on your resources. Now, if you wanted to provision these rules in every account across those regions, it's a lot of heavy lifting out there. With conformance packs, you can package the collection of rules along with remediation actions into a single entity known as a conformance pack. Now, you don't have to worry about deployment of each individual rule as well as each individual remediation action. You just deploy the pack as a whole, and then we take care of the rest. So it's meant to simplify your deployment experience at scale. At the same time, conformance packs help in simplifying your reporting experience, because now you can get compliance summaries at the pack level. And then, of course, you can drill down to the resource level to get further details. Another important benefit of conformance packs is that the packs, when they're deployed through the organization master account, they're immutable, meaning the member accounts or the child accounts in an organization cannot delete or modify them. Now, this is especially important from a governance perspective, because oftentimes we've heard customers say that they've enabled a set of baseline checks, but then the application teams ended up disabling them for some reason. So you don't have to worry about that if you're using conformance packs. The third feature that we launched last week is custom configuration items. So this is a very interesting feature, and this enables you to use AWS Config as a single tool to audit the configuration of not just AWS, but also non-AWS resources. So for example, if you have an Active Directory, which may be on premises, and you want to monitor whether the configuration of that Active Directory is per best practices, so you could now use a config rule to check that Active Directory configuration. And the way that works is that you can pull the data from the Active Directory using a connector that we have provided, and then you can call our public APIs to feed that data into config. So this opens up a variety of use cases, for example, checking GitHub repositories that are public versus private. So it really opens up the door to check things beyond just AWS resources. All right, so now let me give you a demo on conformance packs. Okay, so here on the left nav, you can click on conformance packs. This is on the config console. Now, this feature is available in our new redesigned console on the config page. So here you can see the ability to create a new pack or deploy a conformance pack. Let me click on that. So conformance packs uses a YAML template under the hood. So folks, if they're familiar with CloudFormation, they can use this YAML template, and out of the box, we have a few sample templates available. So these are various best practices for Amazon DynamoDB, S3, or IAM. We also have a best practices pack for PCI DSS. So you can use these sample templates, download it, modify it according to your environment, and then upload it back to config. So for the sake of this demo, I'll go ahead and modify an S3 best practices conformance pack. So as you can see, this pack has a number of rules within it. So this is a config rule. And then it also has the remediation action within the template itself. So this particular template has about 6 different rules and remediation actions. So I'll go ahead and upload this template. I'll give my pack a name. I'll provide any input parameters for the YAML template. Hit next. And then I'll go ahead and deploy this pack in my account. All right, so let's wait a few seconds. So there you see the best practices pack for S3. The deployment has completed, and it's already detected that it's non-compliant. So when I click on it, I can get more details within my pack. So this is a list of all the rules within my pack and the remediation action associated with it and the compliance status. So I can click further to get more details within each rule. I can see the remediation action associated with the rule. And then I can also see the list of resources that were evaluated by this rule. All right, so now let me try to delete this conformance pack. So I don't have to worry about deleting each individual rule now or the remediation action. I just delete the pack, and then that takes care of deleting all of the contents within the pack. All right, so that was a demo of deploying a conformance pack in a single account. But now imagine if you are an organization master user and you want to deploy this pack across your entire organization. So here's a simple CLI command to do that. It's basically calling the put conformance pack API. You can specify the S3 template URL, and that's it. So it deployed the pack in my entire organization. Now, currently in my organization, I've got 2 member accounts. So let's quickly log into one of the member accounts and see if the pack got deployed. Okay, so let's refresh the page. So there you see, I have the organization CPAC, and it's already detected a non-compliant event. Same as before, you can see the list of rules and the list of remediation actions. So now let's, like I told you earlier, if you're using organization master, it's immutable. So now let's try to delete this pack as a member account. So I'll select this pack. I'm logged in as a member account. And I'll go ahead and delete this. So as you can see, you get a message saying that you don't have permissions to delete it. So very useful feature from a governance perspective, and to make sure that your central teams, your InfoSec teams, have their baseline policies in place that are not tampered by these member accounts. All right. So let me now give you another demo. So this one is on custom configuration items. So just to show you the demo here, in this demo, I'm going to be evaluating the configuration of an Active Directory using config rules. Okay. So I'll log into my Active Directory server. Now this server could reside anywhere. It could be on premises or any other environment. Now here you can see a list of users in my Active Directory. So if you see here, for this particular user, the password never expires flag is set to true. Now, ideally, from a best practice perspective, you don't want to have users with that setting. You want your users to change their password regularly. So I'll be using config rules to identify a list of Active Directory users that have this flag set to true. So just to briefly explain the architecture here, I have a Lambda function, which is an Active Directory config connector that will basically poll your Active Directory using LDAP polling. And it will then turn around and call our public APIs to create a custom configuration item in config. And then I have a config rule, which uses Lambda function under the hood to evaluate that configuration and then highlight all the users that are violating that particular rule. Okay, so just to briefly show you the Lambda function for the AD connector. This information is also available on GitHub, so you can take a look at the connector in more detail. But essentially, this is information that is publicly documented about user access control codes for Active Directory for various settings. So the password never expires setting has a particular code that you need to look for, which is what the config rule would be evaluating. So you can also see the logic to call the AWS Config APIs to put that information into config. Now, the other Lambda function is for the config rule that I've created. Now, this particular rule it's a very simple rule, where it's only basically going to mark my resource as non-compliant if that flag for password never expires is set to true. Now, these Lambda functions are configured to run every minute. So by now, that information should already be in config. And as you can see, the Active Directory evaluation rule has already detected 3 users that are non-compliant. So I can click on it, and I can get a list of those users. So that was the end of that demo. Just a quick recap. We launched these 2 features last week, Conformance packs and support for custom configuration items. So these features really enable you to do configuration compliance checks at scale across your organization without worrying about them being tampered or deleted by member accounts. And then you also have things like you could use config as a single tool to audit the configuration of not just AWS, but also non-AWS resources. With that, let me hand it over to Manish, who'll talk about how they do configuration compliance at Geoffreys. Okay.
Yeah, thank you, Sid. Thank you, Masonia. Thank you, Sid. Thank you, folks, for your time, and thank you for allowing me to share. I am responsible for cloud at Geoffreys, and part of my responsibility is to provide governance and agility for the business. Generally, those are kind of competing with each other. How do you provide agility and governance at the same time? Governance in the context of security, governance in the context of cost, governance in the context of performance, reliability, pretty much all the non-functionals, right? So that's my role there. Did I get to? So Geoffreys is a diversified financial services company engaged in investment banking, capital markets, asset management, equities, fixed income. We are global. We are in Americas. We're in Europe. We're in APAC. About lean, 3,700 employees globally. 41 billion in total assets, over the last 5 years, so they've done 790 book runs, right, valued over $167 billion. So sizable presence, many financial services products for fixed income, capital markets, investment banking, and so on. So I want to share our journey first, right, in terms of what Geoffreys has been doing in AWS. Geoffreys is presence in multiple clouds. From an AWS standpoint, there's a little more gravity towards AWS. So we are very opportunistic in the cloud, right? So we look at what can go in the cloud, and we started off our journey with development test environments in the cloud. For every production application, there is likely 4 or 5 non-prod kind of versions of that: dev, test, QA, performance test, and so on. And then it oftentimes becomes very opportunistic to say, if I'm not using performance test environment, I want to shut it down, I'm going to save, right? So that's where the journey started. That's where we were able to start learning what the cloud is and so on. And then we quickly adopted DR to cloud. So we were the early adopters of VMC on AWS. It made no sense to us to keep all the DR servers and the infrastructure sitting idle for the most part, not being used. So VMC on AWS made a lot of sense for us. We essentially run a minimal compute, and we SRM all our storage into AWS. So we are meeting aggressive recovery time, recovery point objectives with the DR in AWS. Then we started off with new applications. I want to give some examples, and it makes sense, right? So oftentimes we have all databases in our on-prem data centers, and the databases are constantly growing. So we came up with the architecture to archive databases to the cloud. So we started to archive databases to the cloud, pull data out of the database that's not being required or not being needed on a frequent basis, put it on S3, and then have Athena query the data on S3. So it's all serverless. It became a very cost-efficient solution. At the same time, allowed us to maintain the cost of storage on-premise. Then, of course, analytics, right? We are a lot of data, petabytes of data on S3 and so on. So we have a lot of opportunity in terms of running analytics. So we are a big consumer of Glue. We are heavy consumers of Athena. We've been running products like Databricks and so on for ETL, machine learning, ML models, so on, with a lot of the new applications that we're building in the analytics space. Digital, of course, as we build models to help our customers, we need to interface with the CRM systems, right? So that's where we are actually enabling a lot of, AI, ML type capabilities back to the business, to the CRM products that we're using. And then largely, as we do all this stuff, we've rolled out many production critical, mission critical applications now in AWS. So this is, it's kind of a busy slide, but I want to share a lot of different perspectives here. So if you think about security of the cloud, I'm just curious, how many of you are responsible for security in the cloud? Okay. And how many of you are in development? Okay. Thank you. So I believe you have to be secure in the cloud. There's no questions about it, right? And there has to be better ways and simple ways and to enable security in the cloud. You can't really compromise security. So if there's security off the cloud, and there is security in the cloud, right? There's those two separate things. For the most part, security of the cloud is taken care of by AWS in this context. But security in the cloud is where the customer has ownership in terms of how you build security in the cloud, right? Now this gets a little tricky because now we have many products, many services, 130, 40 plus services that are out there from AWS. And these services, you can think of them in 3 different categories, right? There are infrastructure services. So things like EC2, VPC, they're like infrastructure services. You can think of container services, right? That's typically how Amazon phrases this. So RDS is a container service. Amazon MQ is a container service. Potentially EMR is a container service, right? So this is a second-class category of AWS services. And then comes the abstracted services. Abstracted services is things like S3, things like SQS, things like SNS, right? So you can see as all these different service categories, the security responsibility for the customer for AWS kind of varies a bit. If you look at abstracted services like S3, AWS offers IAM all the way up to the customer. If you look at infrastructure services like EC2, AWS offers IAM up to the control plane, right? They allow you to build IAM as to who can launch servers, who can update servers, shut things down, and so on. So when it comes to abstracted services, there's a lot of ownership on the customers to do it right from a security standpoint. So if we quickly walk through some of these controls, at the top is the public block, right? In most cases, you don't need S3 buckets, S3 objects to be public, right? So AWS offers a control that offers you to block public access at the S3 bucket level, right? So from a Geoffreys standpoint, we have a requirement that data needs to be private, and we enable public block for all our S3 stuff. The second context is the TLS, right? You want to encrypt, you want to have data in transit to be encrypted at all times. You want to have prevent eavesdropping, tamper-proofing, right? And you want to provide perfect forward secrecy and so on. So TLS is mandatory; it's required. So that's another next set of controls that we have implemented for S3, right? If you come down next, KMS. All data for us, our requirement is all data in the cloud needs to be encrypted in transit, needs to be encrypted at rest. Regardless of whether it's test, dev, QA, prod, doesn't matter. All data needs to be encrypted, right? So we have a requirement that all data, we are using KMS CMKs to encrypt our data in the cloud. And what I really like about that is that when you enable KMS CMK for your data in the cloud, for S3 as an example, anonymous access will not work, right? You have to explicitly give KMS key usage rights for that data accessed from S3, right? Enforce IP restrictions. Within the bucket policies for S3, you can say, I am going to put a condition in there that says this data can only be accessed if you come from this set of IPs. Enterprises will have IP addresses that are external facing. So if you put IP address conditions on your bucket policy, you essentially restrict access to buckets from within your data center. So if you think of a large firm that was recently compromised with a server-side resource forgery, and data was then accessed from outside of the enterprise network for that firm, and of course, there's a lot of loss in terms of personal information, right? If something like IP conditions were applied, that would have probably prevented that. So again, this is another one of those controls. S3 private link, right? So S3 has been, the private link with S3 has been out there for many years. For us, it's a requirement that all S3 access should come through private link as opposed to on the internet, right? So from a networking standpoint, this actually is a cost saving as well. If you have S3 that you're accessing over the internet, then you're paying for egress charges over the internet. They're more than the charges over the private link, right? Over your direct connect possibly and so on. And then it's much higher performance as well. Least permissive model, right? So obviously aligning to some of the security principles. Least permissive model is something we use. So if you need to offer gets but no puts, no gets, multi-part, yes, no. You could do all those sort of least permissive permissions, and we're doing that, part of our Geoffreys requirement for S3. Now from a audit logging standpoint, the S3 offers object logging, server access logs as well. So anomalies that come across, if there's a large get operation, those things can be detected if object logging is enabled, right? And who creates the buckets, stuff like that are also logged in server access logs, right? So that's right, kind of provide the visibility. So that's for S3, it's a requirement at Geoffreys to enable that sort of visibility for the service for the S3, right? And the last three sets of services over there is really enabling SecOps, right? The SecOps team to be able to detect any violations or any issues, and then be able to quickly report on it and take an action on it. So you can see that this is a very broad range of controls just for S3, and this is not everything, right? Like what was announced, this is an evolving set of controls. What was announced, I believe on Tuesday with the Access Analyzer, that's awesome, right? That we'll be able to put that in there as part of the controls we're looking for. One of the things that we also do, it's not here, is DLP. We want to make sure that we enable DLP for data that's out there. Some of the things around tagging is not here. So you can see that this is a very broad set of controls for one service. There are 130, 40 services like that are out there. So this becomes a fairly intense effort when you're evaluating a service to say, how are we how are we at Geoffreys going to use it? So kind of if I flip this around a little bit, we're looking at a model where we always start with the prescriptive control enterprise requires us to do. And this may be coming from your CISO that says encrypt everything in the cloud, encrypt at transit, encrypt at rest, implement defense in depth, implement the MFA for privileged functions, things like that may be coming from enterprise policies that are part of your, coming possibly from your CISO and so on. So that's really preventive controls, right? The directional statements, directional policies, and most companies, regulatory, will have those sort of directional policies part of their enterprise. Then comes the preventive controls, right? So many of the controls that you see here in terms of bucket, public S3 lock or TLS enforcement or KMS key enforcement, they're all preventive controls, right? You can't write data into S3 without using a key. So those sort of things are really preventive controls. And to Masonia's point around, using Service Catalog is really awesome way of doing that. That's one of the ways we're doing it. And then, of course, I have later slides that talk more about it. And then we talk about detective controls. Anytime we see, a violation of our policy in some form, we want to be able to quickly detect that, right? Because as Sid pointed out, there's always a chance that there is something that happens out of band, and somebody created a bucket. A developer, maybe offshore, created something that is not conforming to your standards. You want to be able to quickly detect that, take an action, right? So that's where the detective controls are all coming into play. And last but not least, at audit. Audit is going back to the visibility, right? What's going on? How do we know about it? What's the anomalies that are happening in the environment? Things of that nature, those are audit. So if we kind of look at all these controls and you put it into these different buckets is sort of what we are doing at Geoffreys. So we are kind of ensuring that we are secure in the cloud, essentially. So this is an example of what we have done with building preventive controls in our environment. I gave you the controls for S3. There's many. There's SQS, SNS, Kinesis, EC2, RDS, and so on and on and on. What we did was we built Service Catalog products. We built Service Catalog products. We aligned those products to the portfolios. And then we built that in one central account, and we shared it across all the member accounts. We have an account kind of strategy in terms of we build accounts by line of business, by tenancy, and so on. So we have clear demarcation of what's what, and provide the right level of access to the right developer team so that an investment banking developer is actually just working within the investment banking framework within their account. A fixed income developer is working within fixed income account and so on, right? So we built an account structure based on line of business, based on tenancy. So there's an account for dev, test, QA, prod, and we're using the ALZ, Automated Landing Zone, as a starting point. We did this before Control Tower was even there in terms of how we built out the accounts. Then part of the products and portfolios that we built in the service catalog, we shared those with pretty much all our products, all our accounts. And with sharing those things, we're actually maintaining the controls and codified all those controls in one place and sharing those portfolios with all the other member accounts. What I really, really like about that is the launch constraints. I want to give the developers the ability to do things fast, but I want to make sure that the developers are not going to mess it up. So the launch constraints allow me to give developers the ability to launch products within AWS, but at the same time, not having direct privileged access to make API calls to the services, right? So that's really the sort of a big win. Today we have a lot of products. We have EC2, we have RDS, we have Kinesis, SQS, SNS, so on. So developers can just go and kind of request what they want, and it kind of does that. The second part of that is the config rules. This is where all the detective controls are coming into play, where we built config rules in one Lambda functions basically in one account, and then we are doing config analysis across all the accounts. I really like config service. I mean, how many of you are using config service? Awesome service. You have to really look at it. There was just an incident, I think a few weeks back, where we had an application that was working and it stopped working. It's like, what changed? We were quickly able to go back to config and look at all the assets, resources for that application, and say nothing changed from the resources standpoint, so on, right? You have lots of EC2s. You take snapshots. You want to be able to connect the snapshots to EC2s. When you have thousands of servers and thousands of snapshots, if you have a good tagging strategy, you'll be able to identify that. But if not, config service can connect the dots for you, right? So I really like config service. I think it makes a lot of sense, especially in the IAM policy world. You have very complex policies that you have set up. You want to be able to track what changed, when it changed, and so on, and config service can do that. I'm also very excited about the Conformance pack that Sid talked about. Because with all those controls we talked about for S3, I don't want to build the checks and balances for every control in every account in every region, right? I want to be able to package all of that together and essentially run it across all my accounts, across all the regions that we operate in, right? So it's pretty exciting. So part of config rule, we have these governance functions that we run, and then we log everything in a centralized logging account. And from the centralized logging account, we are looking at the aggregated views and reporting to see what has changed in the environment, or what are some of the anomalies, and what are the things we need to take action. In some cases, we are taking automated remediation. In other cases, we are building a notification back to the to the teams to take an action on. The next phase of what we're looking to do is really build the cost governance aspect here, right? The service catalog is great. It gives you the preventive controls. It gives you the ability for the developers to be able to launch and products and resources. But we want to be able to build a workflow. We don't want to see a big bill that is like, well, okay, who approved that? So we are building a workflow with the Service Catalog ServiceNow connector that essentially would create a workflow, something like a developer putting a request in. The request goes to his manager, saying, do you approve this? This is what they're looking for. This is the estimated cost, by the way, of what you're requesting. And then it comes into the cloud team. The cloud team is basically going to look at it saying, yep, makes sense, and then it kind of goes through. So very simple. The AWS ServiceNow Service Catalog connector is really going to be very helpful here, and we're looking to totally automate that process. So last not least, in summary, right, think of security at scale. I think security security first is our strategy. Think in the context of preventive controls, in terms of all the services, to what preventive controls do I need to put in place. And this is an evolving area. There will be more and more controls that will be coming across for all the different services. Detective, out-of-band changes are possible. That happen all the time. How do we detect those? And I think the Conformance pack is great. In fact, what I think one of the things Sid talked about was the custom things. I'm quite excited about that too, because we have DLP that is not present in AWS today. That's external. It's an external system for us. So I want to be able to get the DLP configs right into the config so I can actually look at changes and track config changes on DLP as well. And then last but not least, audit, right? You want to ensure CloudTrail is turned on everywhere. You're able to do object logging. You're able to do server logging. You're getting access log into potentially your SIEM, whether it's Splunk or Sumo Logic or whatever it is. So basically, that's what we have put together. Thank you very much.
Okay, to wrap up, we provided a 4 themed best practice approach. We talked about preventative and detective controls, the outcomes of ensuring your compliance yield to operational efficiency, consistent delivery, predictable patterns for your workloads, developing template consumption, and then finally, enforcing compliance, ensuring compliance, and at the most, for those who are compliant people in here, making you guys happy. So, on behalf of Sid, Manish, and I, we do want to leave you guys with a bit of a call to action. There are a couple of tiny URLs from an AWS Service Catalog, AWS Config, as well as AWS Answers page on how to ensure compliance. We'd love to hear your feedback and would love the opportunity to work with you to get more compliant workloads into production. So thank you guys very much. This concludes our session.